right? Dimensional analysis. Now, there's lots of YouTube videos on dimensional analysis, but quite a few of them that I've seen are a little more advanced than what can help a beginner that's struggling with it. It's not that difficult to learn, but there are some concepts that might be new to you, but they're very important and fundamental, and I'm going to show you what they are. And they begin with something called a unit conversion factor. Okay, conversion factors are, you can look up in a book. You can look them up on Google. 1 foot equals 12 inches. 1 meter equals 1,000 millimeters. These are conversion factors to take you from one unit to another. A unit could be a unit of length. A mass could be grams and kilograms. It could be volume, liters, milliliters, cubic centimeters. These are all different ways. Cubic inches. I mean, that's a unit of volume. Cubic feet. There's a whole bunch of things that can happen here with transferring from one thing to another. And so the way to do that is typically with a unit conversion factor. But there's something when we were in college, we called them unity conversion factors. And although that's technically not correct, let me explain why we did that. If you want to convert everything into a fraction, and then you set these fractions up next to each other, and you cancel out numerators and denominators as you go along. And then what happens is you leave behind the ones you want. You cancel out the ones you don't want, and it becomes a very step-by-step process that's pretty easy to do. And let me show you how. But I mean, let's think of this unity factor concept again. So if I look at a fraction consists of a numerator and a denominator. Okay? Now, if the numerator equals, and let's draw that line and say equals at the same time, if the numerator equals the denominator, then this fraction is equal to 1. Which means I can do something interesting here. I could flip this over. I could put the denominator upstairs and the numerator downstairs, and it's still going to be equal to 1. Okay? Because it is something that's equal to something. Okay? Now, a lot of things are standard unit conversion factors, like 1 foot equals 12 inches and 1 meter equals 1,000 millimeters, that sort of thing. In fact, let's take a look at meters here. We'll say 1 meter. You look it up in a conversion factor book, and you'll see 1 meter equals 1,000 millimeters. Okay? Now, when I see an equal sign, that means I can draw it as a fraction in a dimensional analysis problem. So I can say 1 meter equals 1,000 millimeters. And because this is equal, the top equals the bottom, I can flip it. I could say, well, okay, 1,000 millimeters equals 1 meter, right? But I'm not done yet. I can even rewrite it another way. What if here I'm looking at 1 meter is equal to something. What about 1 millimeter? So if I say 1 millimeter, it's equal to 0.001 meters. So I looked it up in a book here, but that's equal to 1. And I can do one more thing. I can flip this one. I could say 0.001 meters is equal to 1 millimeter. A meter is about, it's like a yardstick, a little bit longer, and a millimeter is about the thickness of these lines that I'm drawing here on with this pen. All right, so these are pretty small. You take 1,000 of them and stack them up, and you have a meter. And so this whole thing is equal to 1. Well, I mean, it's not equal to 1. It's these all equal 1. Okay, this one and this equals this one equals this one equals this one equals 1. So they're all equal to 1. That means we can flip them. All right. Now, unit conversion factors come in 2 flavors. The standard ones, like 12 inches equals 1 foot, and then there's a problem conversion factor. It's a stated problem. So let me give you an example. Let's say you're traveling 60 miles per hour, 60 mph. All right, and I want to know how far you go in 1 hour. And you would say, well, that's easy. If you're going 60 miles per hour and you travel for 1 hour, you went 60 miles. And your brain calculated it, and it didn't tell you how it did it. And you're sitting there saying, well, geez, how am I going to do this? Well, let's make it a little bit harder. Let's forget this. Let's say you're traveling at 59 miles per hour. All right. And you want to know how far you've traveled in inches. Okay. How far traveled in inches. Okay. Let's say in 37 minutes. Aha. Now we've got an interesting thing here. So your brain can't cancel that one. I mean, it doesn't want to calculate that one. But unless you're some kind of genius. But we can do this. Okay, we can say, all right, well, we can't write 59 miles per hour because from an algebraic standpoint, it's useless to us. We have to write it as 59 miles in 1 hour. Or 59. In this case, it's like a unit conversion factor because it's part of a problem. So in this case, 59 miles does equal 1 hour because it's just part of this problem. So we can make that assumption. We can say, all right, for this problem alone, 59 miles equals 1 hour. And we're using that same format. Now, what I like to do is when I have a problem like this, I like to set up something called a picket fence. Now, picket fence is just a series of fractions where you cross out the numerators and the denominators, and you cancel out those that you don't want, and you keep the ones that you want. So we need to end up, this is our target. So when we set up these problems, on the left side of the page, you use your givens. So this is a given, okay? And what they're looking for is over on this side. So on this side of the paper, we want to end up with inches, right? So let's take a look at the next fraction here. And it doesn't matter which one we use first. It doesn't really matter. Our distance is up on top. That's an important way to start. I wouldn't want to say 1 hour equals 59 miles because we'd never end up with inches in the denominator in our final answer, and that wouldn't work at all. So our length or our distance is going to be in the numerator right from the start. And but we're going to cancel out miles. So it's up in the numerator, so I'm going to cancel it out. I'm going to go down here. Well, actually, yeah, that'll work. Okay, so we're going to take 59 miles, and we're going to put miles down here. Okay. And I need to get miles into inches, and so how am I going to do that? I can't look up miles. There's probably no place other than maybe Google. But you're supposed to be learning how to do this without Google. There's no place I can do it. But I do know something else. From 5th grade, I knew that 1 mile is 5,280 feet. All right? Now I can cancel out miles. Right? So here we go. Now we got feet. Okay, 59 times that many feet in 1 hour. Whoa, 59. Well, the miles are gone. So what do we have here? 5,280 feet. We need to cancel out hours. Well, no, let's get this in inches. Let's go right to inches. So we'll put feet down here and inches here. And in 1 foot, we have 12 inches. All right, so now I can cancel out feet, right? No big deal, right? Now, what do I have? I have I've got inches per hour, and what we're going to do now is we need to get this hours. Now I'm focused on the hours, so I'm going to put hours upstairs, all right? And I'm going to put minutes downstairs. Okay, and that's going to give us, in 1 hour, there's 60 minutes, okay? So let's cancel out hours. And so we're moving the ball down the field here. If that was 60 and this was 60, they would cancel out, but they're not. So I'm going to have to leave that in there. So what do we have left here? We have minutes in the denominator, but what we've got here is 37 minutes here in the numerator, 37 minutes. But I don't have anything to put in the denominator here, so I'm going to put a 1. You can make a fraction out of anything by making it over 1, because you're not really changing anything. So we got that. So this is forcing me to put the minutes in the numerator because I need it there to cancel out this minutes in the denominator. So we're going to cancel that out, right? And so now I have my answer in inches, okay? But I need my calculator. So let's take a look at the calculator. And we should be able to do this all in one little step here, okay? What do we have? All right. We're going to take 59 miles times 5,280 times 12 divided by 60 times 37. And that gives us a huge answer. It's 2,305,248 inches. And that would be technically the answer to this problem. It is technically correct, but there's a problem. It's something called significant figures. All right? And significant figures are going to come into play here. So let's take a look at significant figures here. Significant figures, this is like a chain, all right? And a chain is only as strong as its weakest link, all right? And so what we're going to look for here is whoever has the lowest number of significant figures is going to be all that we can impart on our answer. Because, again, this implies an accuracy that doesn't exist. What we have to do here is say, well, we're limited by whatever we have here. And there's a couple of simple rules. Significant figures is not something that you just learn right away. It takes practice, and there's a bunch of rules that you need to follow, and there always seems to be an ambiguity somewhere. And so my advice to you, and especially at this stage of the game, when you're dealing with significant figures and you can't figure it out, use 3. All right, if it's an exam or a test or something like that, use 3, unless it's specifically asking you for the correct significant figure. It's like if you're doing a lab report or something like that, and you're going, "Oh my God, where do I start?" But let me show you the logic behind this here. All right, any conversion factor, okay, a unit conversion factor that has whole numbers in it, okay, let's call these sig figs, okay, is going to have an infinite number of significant figures. So the significant factor for 1 hour equals 60 minutes. That's a time. It's a unit. You can look it up. We all know it, and it's going to have an infinite amount of significant figures. 12 inches equals 1 foot, same thing. There's no ambiguity there. It's a unit conversion factor. These are whole numbers. It's got an infinite number of significant figures. What about this one here? 5,280 feet in a mile. Again, that's a standard textbook value. No ambiguity, whole numbers everywhere, and that's got an infinite, okay? How about 37 minutes? Well, 37 minutes is part of the problem. It's probably going to be a measured quantity. So we are kind of stuck. It's not really a unit conversion. We're sort of stuck with, if they wanted us to know exactly 37 minutes, they would say 37.00000 minutes. And that would give us, a lot of significant figures where we might be able to keep this answer. But they're just saying 37 minutes, so it only has 2 significant figures. All right? The same thing with 59 miles per hour. If you're going 59 miles per hour exactly, this is where ambiguity comes in. If you're going 59 miles per hour exactly, this would be your answer. If that was exact and that was exact, but they're not. In real life, we wouldn't, if we wanted this kind of accuracy, we would say 37.0000001 minutes, and we would say 59.00000 miles, but we don't. So we only have 2 significant figures here too. So these two are sort of a tie. So that means we can impart only 2 significant figures to this answer. So we're going to use these 2 right here. All right. And since 0 comes after the 3, if that was a 5 or greater, we would change that 3 to a 4. So our answer would be 2.3 times 10 to the 1, 2, 3, 4, 5, 6, 10, 6 inches. Okay. from an engineering standpoint or a scientific standpoint, we would just simply say 2.3 million inches, because 10 to the 6 is a million. So that's how that would be read. And that would be the answer to this problem. And that is the beginning of, let's say, for beginners. And good luck with your dimensional analysis problems. I will add more videos and make it more complex and talk more about significant figures. Thank you. I hope you enjoyed this video. If you did, please press like or subscribe or do both. Thank you.